Hi Bobby.
Hello Aniruddhan.
What shall we do today?
So last class we discussed about half wave rectifier.
Yes.
We were dealing with half of the cycle.
That's true. Let me redraw it so that people will remember.
Yeah.
So we had a sinusoidal signal that was connected to a resistor using a diode.
Yeah.
Correct?
Yeah.
So some RL, this was some diode D, and we said this is Vs was Vm
Sin omega.
T. Correct.
And output we marked as V naught. No?
Correct. Output we marked as V naught. And in fact, I'll also draw it here.
Yeah.
So that students will remember. So we plotted V out. So when sin omega t is positive, the diode will be turned on.
Yeah.
And let's assume that's an ideal diode.
Ideal diode.
So you will get the half sinusoid till t by 2, and then sin omega t becomes negative. Diode is off, so you don't get anything.
Yeah.
Correct?
Correct.
And then
this
repeats, right? So that's what we saw.
I think we also calculated average value of the
Correct.
signal.
That is true. That is a very...
We got it as
Vm by pi. Correct. So we also calculated this. Perfect.
Suppose if we flip diode, what will happen?
Okay. Let's see. Okay. So let me redraw that circuit.
Yeah.
I'll draw this. We're going to take the same thing, except flip the diode, right?
Yeah.
That's easy. I'll just change the direction of the angle like this. Easy, no? So
positive cycle.
Yeah, positive cycle, sin omega nothing, no current. Negative side it will conduct, right? Okay, that's easy. So I'll draw that. So maybe I'll call this V naught prime.
Yeah.
And now 0 to t by 2 there is no conduction.
Yes.
Right. So it will be here 0.
Yeah.
And then I'll get the negative half of the cycle.
Exactly. Yeah.
That's all, no? So till t, and then I'll get 0 again, and so on.
Yes.
Right? Okay.
So average value will be negative this time.
Correct.
Minus Vm by
pi. Correct. So we'll just say average value of Vo prime will be minus Vm by pi.
Yes.
Perfect.
Prime symbol.
We will put a prime symbol here as well. Perfect. So if I had taken bottom as positive and top as negative, I would have got plus Vm by pi, right?
Correct.
Sure.
So now is there a way we can combine these two?
Correct. So this each one of these is a half wave.
Yeah. Ideally, we want to flip Vo prime.
Correct. We ideally want to switch Vo prime, right?
Yes. And add to V naught.
Add to V naught. Correct. Because we want to get signal also from t by 2 to t.
Correct.
But we don't want the original sinusoid.
Correct.
We only want positive.
Yeah.
Okay. So clearly, if the diode is like this, the diode is changing direction fully. So I don't think just adding a diode in that direction here or here is going to help.
True.
No, it'll. In fact, if you have two back-to-back diodes like this, no current can flow. No.
Yeah.
So anytime you have a circuit like this, no current can flow.
Correct.
Right. So we can't even have that.
So we have to think about some new strategy.
Correct. Let me see. What shall we do? So we need to give a path, right, for current to flow in both half cycles.
Okay. And current has to flow in the same direction on both half cycles.
That is correct.
Through the load.
Through the load, right? I think it's going to be difficult if you are going to take RL as ground, connected directly like this.
Suppose if I have another diode from here, from the top, will it help?
Let us see.
We can try.
Let's try. Okay. So what you are suggesting is I take this one and put another diode, no?
Yeah.
Okay. Can I if I complete this, it will just short circuit the load, no?
That is true.
So in fact, first thing I have to do is disconnect this.
Yeah.
No?
Yeah.
Because I can't short circuit the load.
Correct.
But I can do this, no? To complete. Can I not do
We
this?
can do that.
This will work, no?
Yeah.
Okay. But this diode is
There is
bypassing this
no-
completely, no?
yeah.
So all the current will just flow like 1/2 cycle and nothing. Correct?
But if we have from the bottom,
It will be nice if I had 2 RLs.
yeah,
But then, right?
yeah. Or we'll keep this in the RL side.
In the RL side, let's try
We'll
that.
try.
We'll try that. So, what I will do, here, from here to bottom, like that?
Or in the same way you have drawn.
Same way I have drawn, but in this direction,
Yeah.
no? That's what you said.
Yeah.
Okay, let me draw this a little bit better. I'll just draw it as a straight line. Something like this?
Yeah.
Okay, so current seems to like to flow here, no? Okay.
Positive cycle.
Positive cycle has not changed.
Yeah.
Now negative. So now we can't connect here. So shall we try connecting? Shall we try connecting like this to V0? Huh?
Yeah.
Maybe that might work, no? So like this. I'll remove this. We'll clean up the diagram to look nice.
Yes.
We'll just get the basic concept right.
Yes.
So like this. So this allows current to flow in the same direction.
In the negative.
In the negative half
Negative
cycle as well.
cycle.
Correct? Oh, it needs to be in the opposite side, no?
Yeah.
So because this is negative.
Negative.
So we now need to change the direction of the diode.
Yeah.
Like this. So that when Vs is negative, current can flow like this, no? Okay. But we need to complete the loop. This side it can't flow.
Correct.
Shall we do like this? Something like this? Will this work? I know it's a messy diagram. So in, shall we show the, let's see if this works.
Shall we mark current flow in some?
Correct. So that's why I'm taking blue like this. This
So
is positive half cycle.
Half cycle.
Positive half cycle. Then negative half cycle. Current can, it went out like this, no? It doesn't work, no? I have 2 diodes. This can work, no?
Yeah.
So current can flow like this in the negative half cycle. Is this correct?
This diode is correct, but this one.
Cannot, no?
Yeah.
Well, correct.
So in the negative half cycle, the bottom is more positive than top.
The top, correct. So it needs to be
so
like
this
that, no?
diode is.
Needs to be the other way.
Yeah.
Correct? Okay. Yes, correct. This is correct.
So positive, we have current flow like this. So both times now.
Current seems like current can flow.
We have current.
We have current
in the
flow,
same-
correct?
Same direction.
So only thing is we actually broke open the connection from RL to the source, right? So let us see if this is right. So in the positive half cycle, blue color,
yeah.
current will
Plus
flow.
minus we can mark.
We can mark plus minus like this.
Yeah.
Current will flow. Now what I will also do, I'll mark the numbers of the diodes. D1, D2,
Yeah.
we'll say D3 and D4.
Yeah.
So current will flow in the positive half cycle, plus and pluses on the top, minuses on the bottom. Current will flow from the positive side through D1, RL, D2 and then back.
Source,
so the loop is nice and
Yeah.
built. In the negative half cycle in this color, so current cannot flow through D1, D2.
Yeah.
They'll be reverse biased.
Yeah.
So then current has to flow through and direction will be like this.
Yeah.
So current will flow through D3, RL same direction and then D4 and then back
Yeah.
to VS.
The green color. Correct.
Green color,
Yeah,
correct,
Yeah.
correct.
Yeah. Now we will redraw it nicely.
We'll redraw it nicely.
Because
Correct.
this looks like.
This looks very messy, right? Maybe shall I just rub it and redraw it?
Yeah, that's, yeah.
Okay, so I'll just,
Or we
I'll
can
write it
draw
here,
here.
rub it,
Yeah.
and then we'll move it.
Yeah,
Hmm?
yeah.
Okay, so let's try to draw it neatly. So RL is now floating, no?
Yeah.
Let me see.
In fact, we can maybe keep RL in a horizontal way.
I think you're right.
Yeah.
Maybe easier to draw it that way, no? Like this.
Yeah.
And to the negative side, I have two diodes connected.
Yeah.
D2 and D3.
Correct.
Right? And they are going to two opposite ends of RL. Correct, no? D3
Yeah.
is going to the upper end.
Yeah.
Okay. So what I will do, I'll draw it like this.
Yeah.
And then same here on the top side
Yes,
as well.
yes, yes.
I have
D1, D4.
D1, D4, correct, no? For the
Yeah.
top. So I'll do the same thing here.
So we'll draw the positive cycle one alone.
Correct, positive
It
cycle
is
is on
D1,
D1 and then
D2.
D2,
Yeah.
correct?
Yeah.
So,
So
shall
D1,
I'll show D1 like this.
yeah. And then D2.
D2 like this. Perfect.
Yeah. So this will just show positive.
Positive, correct. So then I'll also mark voltage directions.
Yeah.
Okay. And D3, D4 I now have like this, no?
Yeah.
Okay. So now I need to send, this is positive.
Correct.
So now I need to send current like this.
Yeah.
This is correct?
Exactly.
Okay. And then now it flows in the same direction and
Yes.
then like this.
Yes.
Is okay?
Yeah, yeah. Okay.
I'll get
D3,
direction.
D4.
So this direction is also like this.
Yeah.
So this is bottom side is D3, the other one is D4.
Yeah.
Oh, perfect. Okay, this looks much nicer. Huh?
Yeah.
Shall I remove
Yeah,
this portion?
we'll erase that.
We'll erase that. I think
That was our invention part.
correct, correct. Okay, very good. Nice. So now
We'll just mark VS also.
we'll mark Vs. So Vs is Vm sin omega t.
Yeah. Yeah.
And we'll mark Vo.
Yeah.
It's the same direction for both.
Correct.
Let's draw it.
Yeah, we'll maybe draw VS and then V0 below.
Correct. Correct. That's a very good idea. Let's do it. So like this.
Yeah.
This is Vs, Vm sin omega t.
Yeah.
And if I draw Vo, okay. Okay.
Positive
So,
cycle D1, D2 conducts.
and it is just Vm sin omega t.
Yes.
So I'll just mark these points. T by 2, T, 3T by 2. Maybe I'll show those colors.
Yeah.
Positive
Yes,
side.
yes.
So it is positive. Negative side, D3 and D4 will conduct same
Yes.
direction.
Yes.
Okay, nice. I'll get something like this. And now third positive side, I'll get something like this and so on.
Yes.
Oh, nice.
Nice.
So now we have filled in that missing blank space as well.
Yes. Yes. In the same direction.
In the same direction. Correct. Correct. Nice.
I'm curious to know the average value.
Average value. Okay. Okay.
It may be straightforward.
It may be
also,
straightforward, no?
because we know the average value of half wave,
Correct. Average value of half wave we said was Vm by pi.
Vm by pi.
So we had only half the cycle.
Yeah.
Now if you have another half, it must be twice that,
Just
no?
twice that.
Just twice that. Okay. Okay. So then average value of V0, we'll just note it here.
Yeah.
Oh, perfect. Okay. So we got an even. We are using the source in both half cycles.
Correct.
Right. A little bit more efficient, I think.
Yeah,
We are
yeah.
not discarding.
Yeah.
Okay.
Maybe only small differences in the half wave. When you use practical diode, approximately 0.7 was getting dropped in the
Correct.
positive side.
That is true.
Now that will become
2 into 0.7.
2 times
That is true.
because 2 diodes in series.
That is true. In a practical sense, it's a
Yeah.
if the voltage is large enough, then it is not a problem.
Correct.
But if it is too small, it's a problem.
Correct. Suppose if the load is not there,
Okay.
then will I get
I see. If the load is not there, you won't get anything.
exactly?
No? So you have to connect something there.
Yes,
Correct.
because otherwise there is no path for current to flow.
No path for current to flow. That is true. So RL, I'll just make a note of that also. So RL has to be connected, no?
Yeah.
I'll just note that down.
Yeah. Also, if Vs is a grounded source, if one side is grounded, then V0 is not with respect to that. I mean, it's what we have drawn is the
It's a floating load,
floating-
no? It's a floating load. We'll make note of that.
Yeah.
I just thought I'll note down everything. You said
Yeah.
2 diode V on drops, no?
yeah, correct.
So from Vs to Vo.
Yeah.
And then RL is floating. Sometimes it's a good thing, sometimes it's a bad thing.
Yeah.
Right?
Yeah.
So, okay.
Because when we were doing experiments, no, if you use oscilloscope with
Correct.
I mean 2 terminals, one always connected to ground.
Ground.
If you connect any I mean probe across this, one will be grounded and then it will be a problem.
It'll be a problem. Correct.
So I think, but with the kit that we are using, there is no problem.
I think there's no problem. It's always a grounded output that can
it
be
can
measured.
measure the difference in voltage.
It can.
We'll find out.
We'll find out.
Yeah.
We'll find out. Correct. We'll find out. I think it should be able to.
Yeah.
We'll find out.
So when we say RL is floating, both terminals are available to us.
Correct. That's right.
The other load is grounded load,
Grounded load.
where one terminal of the resistor is always connected to ground.
Correct. So you have either like this, or like I'll just draw it in a different orientation.
Yes.
Something like this.
Yes.
Right.
Yes. So if we have a load like this, grounded load, then we
You can't
cannot
you cannot use this, right? Correct. And if you have an RL like this, you cannot use it with the half wave rectifier also, no?
Yeah.
The other end is floating.
Correct.
I guess you could technically connect it to this.
Yeah.
But sometimes
if the source is grounded,
if the source is grounded, it
terminal is
causes
ground, then you can.
Correct. That's what I meant. Correct.
Where we use these rectifiers
One thing I noticed is that
it
became all positive, unidirectional, right? The only unidirectional circuits that we know are DC circuits, no? AC, all the AC circuits we have seen so far, you have full sine omega t, and
that's true,
right? So
even the cell phone chargers may be having some kind of rectification. Because we connect it to 230 volt 50 hertz.
Correct.
That is sine wave.
Correct.
But what is going to the cell phone is positive.
It's positive only. Correct. So most likely they will use either this, or nowadays they have what are these switched mode power supplies, buck converter, boost converter, things like that. So I think depending on the exact application, they might be using one or the other.
Correct. So in general, if you have a DC load to be powered, this could be one of the options.
Absolutely. And this has a lot of advantages to it, no? It's very simple and very cheap also. Right?
Just 4 diodes.
It's just 4 diodes and you have, the load connected and you're good to go.
But when we talk about DC voltage, if I take it from a battery, this is not the shape I will get.
This is not correct. That is true. Right? So that is true. So you want to do AC to DC.
Yeah.
But what you are getting is
unidirectional.
Some unidirectional.
Yeah.
You're getting.
But this is like a road with a lot of gutter.
Correct. Or if I go to the beach and see the ocean, no, it looks like that, no.
Correct. Correct.
The waves will be there on the ocean. It looks exactly something
Yeah,
like this.
yeah.
Correct. Or nowadays, many places they are putting these kinds of speed bumps, small, and you go over them. It forces you to go slowly.
Yes. Yes.
Right.
So, is there a way I can make it closer to the DC?
Okay.
Somehow smoothen this.
That is true. So, in fact, we want a DC like this, no? 2 Vm by pi. The average value is what we want.
Yeah.
Correct.
Maybe if you know how to do this for half wave, then full wave may be easier.
Easier. Okay. Let's
Whether we should name this guy?
Correct. We should name it, no? So, we'll call this the full wave rectifier.
Full wave rectifier.
Yes.
Yeah.
Correct. So, you want to do AC to DC,
Yeah.
no?
I
So
want to smoothen this, bumps.
Correct. Okay. I have heard some people calling it the ripple,
Oh.
right? Sometimes when the voltage does like this, some people call it ripple, there are many names for it. So, but we want to have only a constant, what looks like a battery.
Yeah.
Right? Let's start with this.
Yeah.
This is easier to, I think, probably understand.
Here we have to fill between two bumps.
Correct, exactly. So I'll take this. See, one thing I noticed. I noticed that, see, Vs had the original sinusoid, sin omega t.
Yeah.
And omega is 2 pi by t, capital T. I'm looking at the output waveform. It seems to have, when I see this portion, no, I look at this portion. 1 minute. I look at this portion.
Yeah.
And I look at the next portion. It seems to look identical, right?
Repeating.
And then most likely it's repeating. It seems to be repeating every t.
Correct.
Right? One half of that t cycle, 0 to t cycle, is I see half a sinusoid, other half 0. Next one is again half a sinusoid, 0, and so on. So it looks like the periodicity of this is also t, right? Of this also.
Correct.
Right? Repeating every t seconds. Right?
Yeah.
So, that means the frequency is some 2 pi by t, no? Corresponding to that.
Yeah.
Suppose I were to try to, we studied a filter, RC low pass filter. Maybe
we have done some experiments.
We have done some experiments also. If I can try to do it such that it removes this periodicity, no? Maybe I'll get something little bit better. Right? What do you think?
So there I had a R and C in series.
Correct.
Suppose here anyway I have this RL load.
Correct. Okay.
So if I just connect a capacitor across the RL, will it become slightly better?
That's true. So I understand what you're asking. So initially our first instinct, so we want to take V0 and send it through something, no? And let me write down the steps. So what we want to do is send it through a filter, RC filter.
Correct.
And if you send V0, you might get some V0 prime, right? And you want something like average value. So this was, and so on.
Yes.
Like this, and this one you want it like this.
Ideally.
Constant. Ideally. And our first thought was to put an RC filter, no? I think this is the RC filter we studied last time. So this could have been V0 and this could have been V0 prime. No?
This V0 prime and the earlier V0 prime, they are different.
They are different. Maybe I'll use a different variable. So I'll call it VL. Let's call it VL. So I could have done this and then taken VL, no? Correct. So this I could have said this, we know this is a low pass filter. It will remove that sin omega t if we had given, it reduces the amplitude, right? So hopefully it will do the same. But you are suggesting even something even better, no? Because problem is I don't know where to connect RL. RL will still be here.
Yeah.
Things like that.
Yeah.
Okay. So what you are suggesting is even better, I think. Let us see. So you are saying take this. So you are saying just connect a capacitor, no?
Yeah, across RL.
Across RL. I will move this a little bit. Like this?
Yeah,
Some C.
correct.
Okay. Oh, okay. But this circuit, it won't behave the same way, no?
It will be, I mean, we can maybe
Let's
analyze.
see, we should analyze it.
Suppose
Because
if RL is not there.
low pass filtering, if you do like this, I can understand.
Yeah.
Right? So but this one,
Let's say RL is not there in the positive half cycle.
Okay. Okay.
Then C will charge to VM.
Diode. Yeah, C will charge to VM. Right? So capacitance will charge to VM,
Yeah,
but it can't discharge.
it cannot discharge.
Correct. So it will charge to
So it will
VM.
hold there.
So till this point,
Yeah,
till VM.
correct.
Correct, it will do, and then once the input goes, the diode gets reverse biased.
Yeah,
Okay,
yeah.
so let's do that on the next page properly.
Yeah,
Okay, I'll copy this.
yeah.
I think this is a
We
good.
can copy these two.
These two, we'll copy both.
This, yeah, V average is correct only.
Yes. Okay. So now that we have added C, okay. So this was VM.
Yeah,
Hmm?
yeah.
You should mark that also here. I'll
Correct,
mark it
correct.
here. I'm just going back and
Yes,
marking
yes, yes.
just to be consistent. Okay. So now for
So I was
circuit,
saying, suppose if RL is infinite.
okay. So let's remove RL for a minute.
Yeah,
Okay. So if RL was not there,
that alone should be drawn.
we'll draw that separately. Done. Okay. We will add RL later. So
we will draw below this.
Or shall I draw
on
in
this
blue?
one.
I'll draw it in blue on
Yeah,
this,
yeah,
right?
yeah.
Okay. I have, so initially capacitor is
0.
0 volts. So the initial VI of 0.
Yeah,
Okay. And at t equal to 0, the sinusoid starts. So then what will happen? Positive half cycle, diode is open circuited. So the capacitance is charged.
positive cycle.
Diode is short circuited.
Yeah,
Correct.
Yeah.
So the current will flow like this.
Yes.
Right? So it will charge and follow this curve till Vmax. Now at Vmax, now the input source starts going down, reducing.
So the
So the capacitor voltage on one side of the diode you have Vm, the other side start reducing, but the diode cannot conduct.
So it will become reverse bias.
It will become reverse biased. So till here it will charge and then it will just stay there, no?
It will just stay there.
Stay there. And after that looks like till it reaches Vm nothing will happen and that's it, no?
So in an ideal condition,
correct,
it will
it
be
just
there
stay constant,
forever.
no? So the capacitor will just charge to Vm and that's it.
Yeah.
I see. Nice.
Now let's say suppose RL is there.
Okay. So now we take the same thing but add RL.
Yeah.
Okay. What I will do, I will add RL in this green color.
Yeah.
If RL is there,
Or should we draw separately?
we'll draw
Because
separately.
later it may get confused.
It may get confusing.
Yeah.
Okay.
Below we can keep.
So this one I'll leave it as it is.
Yeah.
Okay. And shall I remove this also?
Yeah. So even if RL is there, in the first half cycle, it will charge up to Vm, no?
That is true. It will
Because
charge up
capacitor
to
is just connected across RL.
connected across RL, correct. So I'll draw it like this. So correct. It will still go to Vm.
Yeah. Now in the earlier case, during negative half cycle, there was no path for discharge.
That is correct. That is correct. So during positive half cycle, current flows like this. Okay. But now this reverse bias, there's no current.
Yeah.
Oh, okay. But this capacitance can
Will
discharge
discharge through that.
Perfect.
So now there will be some discharge.
Some discharge. Oh, I see. So instead of being flat in the ideal case,
Yeah.
you may see something like this.
Correct. Depending on the R and C values.
Depending on the R and C values and T, how they relate to T. Correct.
Correct.
Oh, I see. So
if
then
it is discharged, and the next cycle it will charge back to VM.
I'll charge back to
and
VM and so on.
Yeah.
Okay. I see. Nice.
So we are.
And you can, if you choose RL and RL large enough and so on, or C large enough, it may just stay flat, no?
Yeah.
I see. Okay. Nice. So we are getting something that is.
We have filled it up a bit.
Filled it up a little bit. Correct. In fact, so this looks like it is. See, I originally wanted average value, no? Positive, DC.
Yeah.
It looks like even just a diode and a capacitor is giving me DC, no?
Yeah, that's true.
Only thing, you don't have a load.
Correct.
So if you don't have a load, you can't use it.
There is no, purpose.
There is no purpose for it. Correct.
Yeah.
Correct. So if you
want a peak detector,
this is very good.
Yeah.
Correct. That's right.
So that means if same kind of capacitor, if you put it in the other full wave rectifier, it may even work better.
It may even work better, correct, because we have this double ripple, no?
Yeah.
So if you put a capacitor across RL, it may work even better.
Yeah.
Correct. We'll let the students think about what will happen.
Like this, there may be better filters.
Correct. And there may be better rectifiers also.
Correct.
Right? Correct. But this is a good starting point.
Yeah.
Correct.